before we start actually investigating the details of tangent and cotangent, I want you to first see the picture of tangent and cotangent. So let's say you have an x-axis, and tangent is going to have, first off, it's going to have some asymptotes, and we will talk about how you find these asymptotes, but they're vertical asymptotes. And so what you'll do is you first find your vertical asymptotes to see where they are, okay? And then what happens is halfway in between each asymptote, your graph is going to cross the axis. So halfway in between, your graph is going to cross the x-axis. And then what you're going to do is you're going to find halfway between where it crosses the axis and the asymptote on either side. So you're going to find about there and there. Okay, and those are going to be where you have some critical points. Halfway in between, so it's basically a quarter of the period, you're going to have some critical points. Now typically, tangent's critical point is going to go up one and down one from the axis. And so I don't know where the y-axis is. The y-axis could be over here. I don't know. It all depends on where your asymptotes end up at. But what happens is tangent right at this critical point is going to match up at 1. And then over here it's going to match up at -1 because tangent goes like this, and it kind of has a little bit of an S going on. So it'll come up through this point and then it'll hug the asymptote. And then it'll come down through the point and hug the asymptote. And it'll keep on doing this. And so the idea is that tangent goes up from left to right. So as I look at it, I'm following tangent and it's going up. And then I go back over here and it's going up. So this would be tangent. So again, what you're looking at is you're first figuring out where these asymptotes are. We'll use a formula for that. Then you're going halfway in between, and that's where it's going to cross the axis. And then your next critical point is going to be halfway in between those points, so at the quarters. And those, you're going to make it so that tangent goes up. So halfway in between, up at 1, we have a critical point, and we follow that up. Halfway in between, down to -1, we have a critical point, and we follow that down, and so on. Now cotangent also has an axis, and I don't know where the y-axis is, somewhere on there. It also has your asymptotes, which you will find using a different formula. You're going to go halfway in between for your first critical point, and that's crossing the axis. And then you'd go at the quarters for your next critical point. And just like tangent, cotangent goes up 1 and down 1. Only this time, cotangent is going to be going down. So you're going to put in your critical points at the quarters and at 1 and -1, and tangent's going to be going down. So it looks just like tangent. However, it's flipped so that it is going down. So this would be cotangent. Again, as we follow from left to right, cotangent is going down. So now we get the fun job of figuring out, well, how do you graph this? So let's try something pretty simple to begin with. So let's say I want to graph 2 tangent of, let's just say, how about 2 theta? Okay, we'll try to be somewhat simple here. So here's the deal. You're still going to find that your details. So you're still going to talk about your amplitude. Now, if you remember, tangent went up and kept going up. So there is no really technically an amplitude, but we still remember how it went up to 1 and then kept going, and it went down to -1 and kept going. Well, the same thing's going to happen here. So for our amplitude, I'm still looking at that number in front, so my amplitude is going to be 2. So when you graph this, instead of going up to 1, you are now going to go up to 2 and down to -2. Alright, now the period. Okay, here's the thing that we didn't look at yet, but the period for tangent is typically pi. Not 2 pi like sine and cosine, but pi. So if I want to find the period, I'm going to take pi divided by b, and b here is 2. So the period for this graph is going to be pi over 2. I'm not going to worry about width of the quarters. We can talk about phase shift there's nothing in here, it's just the theta, so there is no phase shift. And the vertical shift, there's nothing being added on at the end, so there is no vertical shift. Okay, but now for the real work, we actually have to figure out where our asymptotes are. And so here's the deal. Your asymptote is always going to be found by taking b times theta plus c. Remember that part, that whole part of tangent, or sine or cosine or whatever. This whole thing, we're going to take that and we're going to set it equal to pi plus 2 pi n all over 2. I know it sounds kind of crazy, there's a lot of math to do there, but that's what we're going to do. So what that means is this part right here is found right here. So I'm going to take 2 theta and I'm going to set it equal to pi plus 2 pi n all over 2. And now what we have to do is we have to solve for theta. So what I'm going to do is I'm going to get rid of, I'm trying to solve for theta, so I got to get rid of the 2. So because I already have a fraction over here, what I'm going to do to solve for 2 is I'm going to multiply by the reciprocal. So I'm going to multiply by 1/2. That means that theta equals, well, let's see here, multiply those together, it's over 4, so it's pi plus 2 pi n all over 4. Now, you might look at that and think, okay, what just happened? But really what we're trying to do is that n part, this n right here, are numbers like 1, 2, 3. So basically it's which asymptote are you looking at? Are you looking at the first one, the second one? Maybe you want to plug in 0 for n or -1 for n so that you can look all over the place. You can plug in any number for n that's a whole number. And so what I typically do is I will plug in n equals 0. I'll typically plug in a -1 and a +1 just so I kind of get a good variety all over the board here. So if I plug in 0 for n, I'm going to get pi plus 0 over 4. So it'll be pi over 4. Now, if I plug in 1 for n, I plug in 1 for n, I get pi plus 2 pi times 1, which is 2 pi over 4. So on top I get pi plus 2 pi is 3 pi over 4. That's if I plugged in 1. If I plugged in -1, I get pi minus 2 pi over 4, right? Because remember what I'm doing, I'm plugging in -1 here, so -1 times 2 pi is -2 pi. And then what I get is -pi over 4. So here's what just happened. I'm going to put -pi over 4 on the graph. I'm going to put pi over 4 on the graph. And I'm going to put 3 pi over 4 on the graph. So then I get my asymptotes. That's where I put in these guys here. Okay, and then remember now, halfway in between is going to be where I cross the axis, and since I have no vertical shift, I'm just going to cross the axis halfway in between. And then halfway in between those are where I'm going to have my next critical points. This is tangent, so I want it to go up. So if I go over here at this point here, I have to follow it up to my amplitude, which was 2, and I'm going to put a point there. That way tangent can follow it up and then hug the asymptote. And then on the other side of things, I put my point down there, so tangent follows it down and hugs the asymptote. Same thing on the next one, up to 2, down to -2, and then I graph it out. And there's my graph. Wasn't that so fun? Alright, so let's try a cotangent one. So let's try a cotangent one. Let's say that this was 3 cotangent of, I don't know, let's go theta plus pi. just to make it a little bit easy again. So I can still do my other things. I have my amplitude, which is going to be 3. The period, again, cotangent has normally a period of pi, so I'm going to take pi divided by b, and since b is nothing, I'll just leave it as pi. My phase shift is going to be pi to the left, and my vertical shift is none. There's nothing being added on at the end. Okay, now here's the deal with cotangent. When you have cotangent, what you're going to do is you're going to take that b times theta plus c, and you're going to set that equal to, now this time it's pretty simple, just n pi. Okay, so if I'm doing my work here, I'm going to take all of this, so theta plus pi, I'm going to set it equal to n pi. And so now what I do is I take away pi from both sides so I can solve for theta. So theta equals n pi minus pi. And so that's going to be where my asymptotes are. So again, I'm going to set n equal to -1, 0, and 1 and see what I get. So if n equals -1, doing my math, I plug in -1, so I get negative pi minus pi is -2 pi. Then if I plug in 0 here, I get 0 minus pi, that would be negative pi. And if I plug in 1, I get pi minus pi is 0. So as I set up my graph, it's all going to be on the left side of the x-axis this time. Now I could change that. I could start plugging in, for n I could plug in 2 and 3 and 4 so that they end up being over here, but it's not really a big deal. So now I'm going to have asymptotes at 0, so there's going to be an asymptote there, at negative pi, an asymptote there, and at -2 pi, and an asymptote there. Alright, now let's see here, halfway in between I'm going to have where I hit the axis. My amplitude is going to be up 3 and down 3. Now this is cotangent, so as I look at the rest of my critical values, I have to remember that cotangent goes down. So as I'm putting in my next critical value, I need to go up to 3 on the left here and down to -3 on the right. Whoops. And then same thing over here, up to 3, down to -3. Typically we'll graph two cycles just so that you can see a bit. Now you'll notice I am just labeling my asymptotes, and that's all I'm going to ask you to do is just label your asymptotes and then where your amplitudes go. Other than that, you can just draw in the picture.